Let f be a continuous function defined on a closed interval ab. In part A, we talk about what theorem guarantees the existence of an absolute maximum value and an absolute minimum value for f. In part B, we talk about what steps are necessary to find those extreme values of the function. So in part A, we are talking about the extreme value theorem, which we have here. And that theorem states that if a function f is continuous on a closed interval ab, then f attains an absolute maximum value f of c and an absolute minimum value f of d at some numbers c and d in the interval ab. So this is the theorem guaranteeing us that the function attains its extreme values on a closed interval and the function get to be continuous to that. In part B, we talk about the steps needed to find those C and D for which the images are correspondingly the absolute maximum value and the absolute minimum value of the function. And that's what we call the closed interval method. And under the assumptions of the extreme value theorem, that is, a function is continuous in a closed interval, what we do first, step one, is find the values of f at the critical numbers of f in the interval ab open interval. That is, we find the first derivative of f and all the values in the interval ab open interval, that is excluding the endpoints, for which the derivative doesn't exist or is equal to zero. All those points got to be considered in step one. That is, we get to evaluate the function at those critical numbers that are within the interval ab. The step two is find the values of the function at the endpoints of the interval. That is, calculate f of a and f of b, the images of the endpoints. And step three is to find or choose the largest value of the values calculated in steps 1 and 2. So the largest value, or better, the larger of the values, largest of the values from steps 1 and 2, the largest of those values is the absolute maximum value of f on the closed interval ab. And the smallest of those values is the absolute minimum value function on the closed interval. So we make a summary. If, under the hypothesis of the extreme value theorem, that is, a function is continuous on a closed interval ab. In step one, we find the values of the function at the critical numbers of f. Here is of f. Let's put it correctly. So of f. So we find the critical numbers of f in the interval b. That is the values in that interval for which the derivative doesn't exist or is equal to zero. So we got to calculate the first derivative and solve the equation f derivative equals zero and inspect whether the derivative is not defined at some points inside the interval. At all those points, that is all the critical numbers of f in AB, we got to evaluate the function there. In step two, we evaluate the function at the endpoints of the interval. That is, we find the values f of A and f of B. And then we choose the largest of the values calculated in steps 1 and 2, and that's the absolute maximum value of the function over the interval AB. And we choose the smallest of the values calculated in steps 1 and 2, and that's the absolute minimum value of the function over the closed interval. So these are the steps we get to follow each time we want to find the extreme values of a continuous function on a closed interval.